right, we want to look at inverse trig functions today. If we were to look at the unit circle to determine where sine theta is equal to a -1/2, we could narrow that down a little bit because we know sine is negative in the third and the fourth quadrant. So that would narrow it down to the bottom half of our circle down here. And so we would just be looking for where sine, our y value, was -1/2. So here it is right here at 7 pi over 6, and then again over here at 11 pi over 6. So we're going to do something very similar to that with our inverse trig functions. Now, when we talk about a function, remember that you have to, with a graph, it has to pass the vertical line test to be a function, and it has to pass the horizontal line test as well for its inverse to be a function. Now, if you look at our sine curve, would the sine curve pass a vertical line test? Absolutely. Would it pass a horizontal line test? No. But we have to be able to take the inverse of a trig function. And so we can only work with a portion of the sine curve when we're working with inverse trig functions. And that's this highlighted piece from -pi/2 to +pi/2. If you'll notice, that piece would pass both a horizontal and a vertical line test. So for that reason, anytime we are doing the inverse of sine, and we'll denote that as arc sine or sine to the -1, we're only going to be able to use the values for x between -pi/2 and +pi/2. Now, if you think about it, if you start at 0 and you go up pi/2, or you start at 0 and you go a -pi/2 or down pi/2, that gives you the right-hand side of the unit circle, right? That would be the first and the fourth quadrant. What is sine in the first quadrant? It's positive. And what is it in the fourth quadrant? It's negative. So, if they ask me for the inverse sine of -1/2, here's what I know. I know that they are giving me the answer and asking me for the question. So think of it like Jeopardy. Normally they would ask me, what's the sine of 7 pi over 6? And we would say -1/2. Now they're going the opposite way. Now they're saying the answer is -1/2. What's the question? That is the inverse sine. So we're going to call these our Jeopardy questions. And so when we see inverse sine, we know they're giving me the answer and I'm looking for the question. And I also know I only have first and fourth quadrants to choose from. I get all of that from the definition of inverse sine. Since this is negative, I also know that I'm going to be in the fourth quadrant because sine is positive in the first and negative in the fourth. So I'm just going to come down here to my fourth quadrant and I'm going to look for where my y value would be a -1/2. And so you can see that would be at 11 pi over 6 or -pi/6. So if we go all the way around the unit circle, that's 11 pi over 6. If we start here at 0 and we go down pi over 6, that's a -pi/6. Now, I know that those are coterminals and they're two different names for the exact same thing. But if you look at your domain that it goes from -pi/2 to +pi/2, -pi/6 is between those two values. 11 pi over 6 is not. And so for that reason, we want to write it as -pi over 6. All right, look at the next one. So the next one we have arc sine of 1/2. So again, that means we're playing Jeopardy. The answer is 1/2 and we're looking for the question. And because it is inverse sine, we know we only have first and fourth quadrants to choose from. Now, since this one was a positive one, I know that sine is positive in the first quadrant. So that means that I'm going to be looking in the first quadrant for where sine is 1/2. And of course, that would be at pi over 6. Now, we could have that exact same discussion with cosine. The cosine curve would pass a vertical line test. It would not pass a horizontal line test. And so we're going to have to choose a region that we're going to use for the inverse cosine curve. Now, you'll notice that they didn't use the same region from -pi/2 to +pi/2. They're not trying to be difficult. if you'll notice, if you look at negative pi over 2 to positive pi over 2, that still wouldn't pass a horizontal line test. So we don't have a choice. We have to use a different region, and the region that we use is from 0 to pi. Now, if you think about 0 to pi, if we start over here at 0 and go around to pi, that's going to be the first and second quadrant, right? So inverse cosine is only going to be valid between 0 and pi, which is the first and the second quadrants. We also know cosine is positive in the first and negative in the second. So when we come down here and this is a positive value, we know we're in the first quadrant. If it's a negative value, then we know we're in the second quadrant. All right? So when I see arc cosine square root of 3 over 2, I know that means that cosine is equal to square root of 3 over 2, and I only have first and second quadrants to choose from. I get all of that from the definition of inverse cosine. So since this was positive, I know that I'm going to be in the first quadrant, and so I'm going to look over here in the first quadrant and see where is my x value square root of 3 over 2, and that's going to be right here at pi over 6. All right, let's try another one of those. So this time it wants to know the inverse cosine of negative square root of 2 over 2. So that means that cosine is equal to negative square root of 2 over 2, and I only have first and second quadrants to choose from. Now, since this is negative, what quadrant am I in? Well, I'm in the second. And so if I look in the second quadrant for where my x value is negative square root of 2 over 2, you can see it right there at 3 pi over 4. So for inverse tangent, it is the same discussion. For inverse tangent, it would pass the vertical line test, but it wouldn't pass the horizontal. And so we restrict the inverse trig function to just this region that would pass both the horizontal and vertical line test. So that's the piece from negative pi over 2 to positive pi over 2. Now, if you'll notice, that's the same region as we used for inverse sine. Again, it's the first and the fourth quadrants. The only difference is we can't be equal to negative pi over 2 and positive pi over 2 like we can for inverse sine, because that's where our asymptotes are. So if they asked me inverse tangent of 0, that means that tangent is equal to 0. I'm playing Jeopardy. They're giving me the answer. I'm looking for the question, and I only have first and fourth quadrants to choose from. So I'm going to come over here and I'm going to look at my first and fourth quadrants to find my tangent value. Now, remember that tangent is sine divided by cosine. So I've just gone through here on the unit circle and said sine divided by cosine, 0 divided by 1 is 0. 1/2 divided by square root of 3 over 2 is square root of 3 over 3. Square root of 2 over 2 divided by square root of 2 over 2 is 1. You get the idea. All these handwritten values on here are my tangent values. So if they ask me where in this region from negative pi over 2 to positive pi over 2 is tangent equal to 0, it would just be right here. Now, do I want to call that 0 or do I want to call that 2 pi? Well, again, think about your domain. If we're thinking about the domain, we can only give values between negative pi over 2 and positive pi over 2. So 0 is between negative pi over 2 and positive pi over 2. 2 pi is not. And we don't need to give the same name twice. So we would just say 0. All right, look at the next one. Arctan of square root of 3 over 3. So that means that tangent equals square root of 3 over 3. And I only have first and fourth quadrants to choose from. Since it's positive, what quadrant am I going to be in? I'm going to be in the first. So I'm going to use this guy right here. Pi over 6. What if that had been negative? What if it had been where is tangent equal to negative square root of 3 over 3? Well, then I would have just come down here, and remember, instead of saying 11 pi over 6, I would say negative pi over 6, because that's the value in between negative pi over 2 and positive pi over 2. So the only time that we need to write it as the negative angle is when it's in the fourth quadrant. All right, we also can put these into our calculator. All right, so grab your graphing calculator if you would please, and I will switch over to mine. All right, so first off, you want to make sure that you are in radian mode. So check your mode. All you want to do is just hit your mode button, and make sure that you are in radian mode. If you're not, come over to radian and hit enter and it will switch. All right, so if we want to find the arctangent of negative 8.45, all right, you'll notice that right above the tangent button, it says tan negative 1. That is our inverse button. I mean, look at several of the other things. Look right above x squared. Right above x squared is the square root of x, right? Right above ln is e. Right above log base 10 is 10 to the x. The inverses are above the function. So right above sine is its inverse. Inverse sine, inverse cosine, inverse tangent. So I'm going to do second tangent to get that inverse tangent, and then I'm just going to type in the value that we had, which was negative 8.45. So if you're having any trouble getting that, just let me know and I'll look at it with you. All right, the next one that we had was inverse sine, so we're going to do second sine of 0.2447 was the question that we had. So again, if you're having any trouble getting that value, let me know. And then the last one was arc cosine of 2. So I'm going to do second cosine of 2, and I'm going to get an error message. Why am I getting an error message? Well, look at the hint that it's giving you here. It says error domain. So why am I getting an error message? Well, what I just asked my calculator was to tell me where is cosine equal to 2. Think about your cosine curve. Your cosine curve goes up to 1 and down to negative 1 unless it's had an amplitude change, and this is just plain cosine. It hasn't had an amplitude change. So when they're asking me where is cosine equal to 2, nowhere. And so that's why my calculator is giving me an error message. It can't be done.